Morning, everyone. My name is Sonal, and my topic is security fails at the seams. I'll be talking about how we use domain modeling to validate a hypothesis. A really quick introduction about myself. I'm a business analyst. A lot of my experience has been in trying to solve business problems, and I honestly love solving problems because I feel on the other side of a problem, there's always a good story to be told. And I hope this one ends up being good. So like I mentioned, I'll be talking about domain modeling to solve a hypothesis. We are talking about solving a prioritization problem. Now, domain modeling, DDD, it's been used for software architecture, I think, for about 20 years now, since Eric Evans first wrote the Blue Book. But I'm trying to see if we could extend this and think about more the business rather just the technology architecture. So over the next 45 minutes or so, I hope to introduce you to our problem, discuss a few learnings from some initial experiments we did, which predated modeling, or rather domain modeling, and that should lead us to the big hypothesis. When I talk about the hypothesis, some of the modeling and some of our experiments after we had a hypothesis as a starting point, I think by then we'll all need a break from the use cases and security, so I'll take a bit of a self-indulgent detour and talk about approach to problem solving, and then I'll try and wrap it all up in a big bow, and hopefully there'll be something that you'll all be able to take away from here. So what I'll do is I'll start by setting the stage and talking about the client context. So we were engaged by a large financial services company to implement observability, because what they were looking at doing was roll out a proactive risk management program of work. This organization had all the trappings of a large financial services organization, including siloed teams, distributed teams, and because they were financial services, they had a lot of competing compliance obligations distributed across very different regulatory bodies, and that created a lot of manual process overhead over here. So the ask was to implement observability and also to help them with an approach to prioritize these controls. Because when they were thinking of proactive risk management, they needed an approach that could get them there from their current situation of having all manual processes. So I suppose what's unique about security and observability is important in understanding why we needed to get to domain modeling. And when I think of security, I think of the business risk. So at the heart of security is an understanding of business risk. For those of you who are familiar with the principles of confidentiality, integrity, and availability that underpin a lot of security discussions, these principles and are relevant, again, in the context of the business. And really, what is confidentiality, or what is integrity or availability for that business, for their customers, and for the data they're handling? What's also interesting is that when you're now bringing security and observability together, observability by itself is expensive. And it's expensive not just because you're trying to see what's happening, but you're trying to see what's happening in the context of what you want to happen. And so you have all of these security controls, and now you're implementing observability in a large financial services organization, and that can be a recipe for disaster. It's very easy to go down rabbit holes and start having implementation conversations rather than bringing it back to the business risk and thinking about the business. So Therefore, very naturally, we did not start thinking about business risk. And where we started was with component diagrams, because our goal was observability, right? That's what we were thinking about, and that's the only goal that we had on our radar. So we started with one. We thought we'd draw a component diagram for every control. We'd identify what the engineering value is. We'll translate it to some sort of a metrics framework, run a cost-benefit analysis, because that should get us to the right approach. We thought these diagrams are perfect because they had everything you needed. They had the actor, they spoke about what's important to the actor, it looked at how things work together, we had the perfect set of metrics. So really, this was the approach we needed to go with. But what we realized as we were analyzing one control at a time is that this does not talk to the risk at all. And like I mentioned, security, at the heart of security is an understanding of the business risk. This also does not talk about operational constraints and the impact these constraints have on security. And finally, engineering metrics are great, and I do not wish to undervalue them, but these metrics did not tell us what's important to the business. So at the end of this exercise, there were a few learnings that we took away with us. And the first one was, when our goal is business risk, when we're thinking of a program for proactive risk management, the underlying metrics should not focus on the engineering value. The other thing that we took away from this was that analyzing the implementation metrics for each of the controls would not help with a pattern for a prioritization approach, because they're working at two very different levels. The implementation metrics and any analysis around implementation is specific to that control. Whereas when you're thinking of a program of work for a large program of work that's trying to prioritize, you need a pattern. You need to get out of the individual controls and think about a broader pattern. So that took us to our second attempt. And in here, we decided to move away from implementation. We said, let's look at all of the controls holistically. Let's build a decision-making framework. And we thought, this framework's going to be great. It's going to integrate all of the learnings we have, and it's going to be able to automate recommended controls for prioritization, and it will then also help automating us out of our job. And that was great, because we did that before ChatGPT. So again, this looked perfect to us. If you look at the diagram on the left, it talks about the desirability of controls. It talks about the criticality or the risk. It also looks at parameters such as how easy or difficult it is to implement it and to maintain it. And it had this amazingly complex scoring criteria, one that I'm still very proud of. And it was able to give us this view of prioritized controls in the upper right quadrant. I suppose you're waiting for me to tell you what was wrong with this. So while we thought it's giving us a view of the risks that are critical, it actually wasn't. Because what it was doing was telling us the view of the risks that were critical based on the people we were speaking to. It wasn't telling us the view based on the business and on what's important to the business. And so Because we don't know whose story we are telling, everything that we analyze after that point kind of starts becoming a little less relevant to our goal. So if you remember the first two set of insights that we had from our component diagrams and engineering-led analysis, we learned that engineering metrics are not representative of business value. We also learned that we needed a pattern to get to a prioritization approach. So even though we took those two insights with us, we gained more insights at this point. And I believe there's a Dutch word for progressive insights, which I'm not going to attempt to pronounce. But I like this concept, and I think it resonates a lot with me, because each time we failed, we knew what we needed to take forward with us, and failure actually moved us forward. So what we now learned was that the missing business perspectives were key to our implementation story. Now, the thing is, without those business perspectives, we can tell our story in many ways. We could draw beautiful sticky note diagrams on Miro, and we could talk about translating technical value to business value. But with the lens that we had, regardless of how we tell the story, we're really only telling the second part of the full story. And we're not telling the full story. So to tell the full story and to tell the first part of the story, what we really needed were mechanisms to surface the structures that we had missed. So what did we do? We collaborated, and we used domain storytelling. And I really like domain storytelling as a tool because it uses the subject, verb, object format and really helps retain a lot of the linguistic context that gets missed in process modeling. Interestingly, on a bit of a side note, in conversations around risk and security, the linguistic context was very important, and there was some correlation around things that happen at linguistic boundaries. But we don't have time to go into them in this talk, so I'll park that for another time. And I'll go into the details of this use case. So it was a very simple use case, and I've oversimplified it for this presentation, where we looked at change to a system. For those of you who are developers in the room, the fact that a developer is raising a change request might not sit well with you, but for context, these were developers who were making changes to someone else's system, and they had to raise a request for those systems. So a developer raises a change request. This request goes to a risk owner. The risk owner reviews this request. They then take a decision to approve it, and the developer gets notified. That's the approval process. What then happens is that at some point, the developer implements the change, hopefully at the point they were authorized to implement it. And when they implement this change, it gets logged in a system log. And then, perhaps 6 months down the line, a bunch of auditors come in, they try to understand what's been happening around here, and they start reviewing logs. They figure out what's compliant, what's not compliant. They create their own view, and they then share that with the risk owner. Now, as we were discussing this use case and modeling it and talking about it, one of my colleagues, just looking at something that looked like this diagram, had this epiphany. And he said, so the problem is that security fails at the seams. And if you're wondering what are those seams that he was talking about. Don't worry, at that point, so were we. So you might be familiar with seams on a piece of fabric. That's where two pieces of fabric come together and they're sewn. Now, extending that, if you think about, process design, any element of a process design, whether it's the design, the operation, or the implementation, when there is a boundary between the two, those are the seams that we're referring to. So if you'd like, if we could just visualize those seams, and what my colleague was looking at was broadly these three separations. At this point, it was guided by business process, so approval process, implementation process, and an audit process. Now, there were other boundaries, and we sort of decided to use bounded context as a tool at this point. And for that, I'm going to talk through some of the heuristics we used. But before I just go into the details of those heuristics, I want to make a point about the fact that we made an active decision to think about using bounded context to identify those boundaries at this point. So we were still early in understanding what the domain was and in discovering the domain. We didn't know where the seams were. We knew that as we learn more information, we'll have to modify our models and think through how we're understanding the world. And we really wanted a tool that could integrate the multiple lenses, the linguistic lenses that I referred to, and also integrate new information and give us the flexibility to really understand what was happening. And so we made a choice to experiment with bounded contexts and really see what boundaries are emerging when we're looking at these very high-level business components. So the next point gets us to heuristics. And again, before I go into the heuristics we used, if you're not familiar with what a heuristic is, you might have seen one of these diagrams like the one on the left. It has a collection of ungrouped objects, and there are different ways of grouping it. Now, the shortcut that you use for making that decision on how to group these objects is essentially a heuristic. So when we're talking about heuristics in order to prove this hypothesis, we're really thinking of shortcuts which are commonly understood, and they make sense to people around, and that enable decision-making. I'm sure by now there are a lot of different people with a lot of thought loops, because I think I've been speaking of a few things. So I'm just going to get everyone's attention back to the thread in my head and bringing it all back. So where were we? Our goal was still to implement observability. Like, we haven't moved away from that goal. We knew we needed a pattern, so we had I'm going to call it a working hypothesis, though realistically at this point it was more conjecture. But we had this hypothesis that said security fails at the seams, and we wanted to go hunting for those patterns. And of course, we had a view of process seams, which was our starting point. Now, as we were hunting for the pattern, I just want to rephrase security fails at the seams and talk to what we were really trying to do. What we were trying to do was we were trying to understand that if it is true that security fails when there is a boundary, then we should be able to find a failure condition at every boundary. And to be able to find these failure conditions, or to find the boundaries to test for failure conditions, what we thought we'd do is use 3 different heuristics and test for failure points at every boundary that emerges. Now, You might ask me, why just 3 heuristics? Or why not an entire buffet of them? And I think this is sort of where the fact that we were consultants engaged to get to an outcome kind of starts playing into it, because if we had a lot of time to do an academic exercise, perhaps we would have thought about this in terms of multiple heuristics or thinking about more than just 3. But because we were really trying to, at this point, understand the domain and test our approach, we thought the best way to go forward is to think of 3 of the heuristics that resonated with most of us and start seeing what happens with those. So that's our use case. And if you just look at the approval process and the implementation process, there were controls and there were perhaps things that should not happen between these 2 processes. Because what you want is that when a change is being implemented, it's being implemented by someone who's authorized. It's being implemented, or the operation itself is authorized. And the system that is being changed, which in our context was someone else's system, that is also authorized. And I'm just basically transposing those domain stories into a linear format in an event storm. And if you look at where the process boundary is, it is, as we've sort of spoken about, in the middle of the approval and the implementation process. The next heuristic we thought about using was time, because we were concerned about the fact that once there is a big difference between an approval and an implementation, it becomes a lot more easy to have unauthorized activity. And at this point, time made perfect sense to us as a heuristic. A couple of slides later, I will argue why time perhaps might not have been the best heuristic, but let's park that. And when we're thinking of the time very closely followed the process. So we found the same at the exact same place. When we were discussing the impact of time and why time should be a heuristic, we also started speaking about the fact that as time passes, it creates situations where the integrity of information could be compromised. And that led us to our third heuristic, which was the integrity of information. And again, as we were thinking through the implications of what information could be compromised and where, we ended up with the same theme. Which honestly was not something we were expecting. We were expecting that as we use different heuristics, we'll get more clarity and perhaps find different boundaries. We were not expecting the boundaries to be all at the same place. So that really raised more questions than answers. We started questioning whether we were using the right heuristics. We also started questioning, given how closely these heuristics are related to each other, are we just using 3 different names for essentially what is the same heuristic, and perhaps we should be thinking of a different name and finding a more appropriate heuristic? And we also were wondering whether this behavior would be different at a different level of abstraction. So what if we zoomed into the approval process and started looking at the individual sub-processes and seeing what happens at that point? So same use case, just the approval process. And now we thought, well, if we zoom in, what's the difference that we're looking for? And we said, let's look at the unhappy path, because the happy path is unlikely to give us anything different. And that's what we did. Also, interestingly, as we were sort of looking through the controls we had in this unhappy path, To prevent this unhappy path from occurring, there was actually a control within the organization around ensuring that mandatory information is filled in, because they felt this control would make it easier for the approval process. So it was also a good opportunity to test how useful that control was. So we looked at the approval process and applying the heuristic of a business process. We said maybe there is a rejection process and a resubmission process. It didn't sit very well with us, but we decided to go ahead and see where this leads us anyway. And the reason why it didn't sit very well with us was because we were wondering whether we are now just forcing a business process heuristic on something that's not a process, but just an activity. We then looked at time. It didn't have any relevance. And that led us to the fact that perhaps when we're thinking time and we're thinking of all of the unauthorized activity that can happen in that break of time, we are perhaps concerned more about handoffs. But again, in this scenario, handoffs didn't matter. They were in fact desired. You wanted, if someone was rejecting it, you wanted it to be handed off back to the person who initially raised the request. And then integrity of information followed the time path, where it didn't seem to be a relevant heuristic in the detail of the approval process. So now we've potentially established, that the process seam is not a process seam. There is no process. It's just activities. Time doesn't matter. Handoffs don't matter. And really, there's nothing that's impacting the integrity of the information. So perhaps what we had on the unhappy path was this massive chasm of unhappiness. And to avoid unhappiness, the business put in a control to improve operational efficiencies, but there was no impact to the risk and to security. So we had some learnings out of this. The first one, of course, was that every activity is not a business process. Even though the heuristics seem to not give us an outcome in terms of our modeling and understanding of failure points, but they did help refine a lot of the conversation. And when we think about the control that we spoke about, the one around making sure that the mandatory information is available, it was very clear the value of that was operational efficiencies. So there was no impact to business risk. And in a way, we started seeing something emerge out of that, where we started seeing that in the first scenario, where we had a broader view, we did find failure points at a boundary. And as we moved along into this zoomed-in view, because the entire context was within the boundary, we didn't really see failure points. Now, that led us to something related to change, but not exactly change, and we started speaking to the teams that were looking at infrastructure resilience and specifically installing patches. We liked the idea of exploring this area because we all know how important patch installation is to being secure. And we thought this would be great. It'll give us all of those process seams, time seams, handoff seams, and we'll really have an output that we could use. So if you are able to read what's on the sticky notes, it's pretty simple. Looks at the availability of a patch, updating the information that a patch is available, planning for installing the patch, and then testing that the patch is all working fine. And if we were to draw an analogy with change, there was perhaps a likely business process seam where the patch has been scheduled and the patch is to be installed. But for that seam, when we were thinking of failure points, there were failure points beyond just that seam. Because if your systems are not patched, you can have a failure point anywhere, right? And again, as we're looking at time, we're looking at handoffs, we're looking at the integrity of information. At this point, we were really wondering about why is this really not aiding the conversation we want to have? Why do we feel that we're doing something really futile and that we're not getting anywhere? Is this just as bad as drawing component diagrams? So as we are sort of thinking through this and having conversations and trying to model the context within the organization, the context outside of the organization, we start seeing this very interesting thing happen, where there are events not just within the organization, but events outside the organization that lead to security failures. And what that led us to was the realization that the domain of security extends to events that are happening outside our organization. So I could talk about a few more use cases, but I think I'm sure you get the general idea of where this is headed to. So at the end of this, we did not make any breakthrough in the field of security. But what was very interesting was that the more use cases we analyzed, the more we started finding that pattern that we were looking for. We found that when you find those boundaries or those seams and test the impact of failure at a boundary, it correlates more closely to a security risk and the need for a control than if there is no failure, than if you're looking at something or two events just within a context or within a boundary. And I think in addition to all of that, as we sort of looked at our use cases, what we started finding was that the fact that we were collaboratively modeling the domain and working through the implications really aided decision making. And that was a big win for us. So here's the point where I'll park the use cases and take that promised detour into navigating ambiguity. So if you remember the slide, which by now I've shown a few times, we were thinking we were there to implement observability. But also, we were there to recommend that approach for prioritization. And when I think of things like prioritization or shaping work, I think of them as mechanisms that help get clarity. Sure, those are activities that we do, but eventually they aid the objective of getting clarity. And the really interesting thing is that as humans, we're doing that all the time. You wake up in the morning and you have a plan to get to work. It is a very ambiguous situation, but you don't think of it that way. What happens if your cat falls sick? What happens if there is something else that needs your attention and you cannot get to work? But none of us wake up in the morning and go into this complete state of paralysis because we don't know how to navigate the ambiguity of the day. So you're not even thinking about your cat as you wake up. Maybe you are, but for totally different reasons. And why is that? I'll use a very standard, simple, well-known information architecture framework that would help guide this. So you wake up, you've got intent. You've got the intent to get to work. And then reality hits, which is the cat's unwell. Now, if you're someone like me, what you're going to do is you're going to ask your partner to take the day off, and you'll still get to work, perhaps in an Uber, but you're going to be there. So you've navigated this ambiguity without even realizing that there was ambiguity that you're navigating. So while you love your cat being unwell doesn't send you into the state of paralysis. Now I'll concede that software is a lot more complicated than waking up in the morning and getting to work. But I think the underlying framework that helps us navigate ambiguity still is applicable in the software world as well. Because what we all have is a lot of charts, frameworks, graphs, maps that we're always able to play with and adapt. And we think when we're doing that, if you think, what's the purpose of this chart or this framework? It becomes easy to adapt, and then when you're collaborating and sort of visualizing what's happening, that aids the process of being able to adapt that. And that's what I think worked in the scenario that we had. So a lot of us have been told, like, I've heard it throughout my career, and I've heard people saying, if you really understand this, you can tell me like I'm 5. And I'd ask, well, if we really understand how best to use our tools, perhaps we should be thinking about them like we were 5. I don't know how many of you have kids, but I've seen 5-year-olds do some very interesting things with tools that no one else has thought of in the room. So, well, I suppose your question is, how did bounded context help our problem? So, going back to the use cases, the first one was in the use case of change to a system. We found that clear seam between the approval process and the implementation process, and the seam was reinforced by other heuristics, and there was a clear indication of the fact that an impact of failure at this boundary impacts business risk. When we think of just the zoomed-in approval process, we found that there really wasn't a seam within that process. So within the context of that process, or the context of those set of things that we were looking at, there was no seam. And without undermining the importance of operational efficiencies, those were not relevant to the business risk and the security conversation. And finally, when we started looking at patch installation, what domain modeling really helped with was understanding this domain, which we realized is much broader than just the events happening within our organization. When we went into the details of that modeling, we found that the failure points are created by events outside our organization, and those boundaries, or those, again, failures at a boundary created, with the domain being broader than the organization, did have an impact to the security and the risk being carried by the organization. So bringing it to the framework, our intent was to have this prioritization approach. We were constrained by the reality of time and money, because if we had infinite time and infinite money, perhaps no one would be talking about prioritization. And then the structure we used was to think about, what's the purpose? What are we really trying to do? What tools do we have at our disposal that we'll be able to adapt that we are familiar with, we can modify and test and see what that leads to. And as we were going along, we were then able to adjust and modify an initial view of things that needed to be done. So thinking about bounded context and its applicability in our scenarios helped us get from this very ambiguous place where everything seemed important. And when someone throws the word security at you, everything is important, right? Nothing is negotiable. So everything seemed important to a place where we were able to identify a set of priorities and bring in clarity of our approach. If you're wondering, hey, what's the one-slide version of your presentation, please? So we had some insights from our initial set of analysis, right? We figured engineering metrics are not representative of business value. We figured that to define a prioritization approach, we needed a usable pattern. And more importantly, no, perhaps equally importantly, the missing domain perspectives, those were the perspectives that were key to implementation. And what did that mean? What that meant was that the domain was what held clues to what was meaningful. Collaborative modeling really helped us understand and identify what was important to decision making. And the fact that we used multiple heuristics, we were able to identify a usable pattern to take into an approach. Now, I don't think there's anyone in this room who's going to disagree with the fact that all models are wrong. We all know it, we all agree with it, we have all internalized it. And if all models are wrong, then now what? Where do we go and why do we model? And I think even though we all agree that all models are wrong, we can always still start from a point of utility. In our case, we started from that point of utility of identifying what's useful to get to those boundaries and to seams. And then we sort of play around with it, test across use cases. What we didn't get a chance to do was to test across different industry sectors and to see how it evolves over time. Because the more we experiment, the more that would lead us to insights. And I suppose the more insights we have, the more perspectives we'll be able to add to our list of perspectives. And it's quite likely the more perspectives we have, the more experimentation we'll indulge in. That is it from me. Thank you so much for your time. If you'd like to chat about it, you can find me on LinkedIn, or you could send me an email.